last class, I discussed about this now, bleaching powder and the baking soda. So in the bleaching powder, we already know that this was the formula CaOCCl2, है ना? And it is produced by the action of chlorine on dry slaked lime. So this is my bleaching powder, and if I'm reacting with this chlorine on a dry slaked lime, then we will get this bleaching powder, right? This is the formula of dry slaked lime. Okay, and we will get a bleaching powder plus water. Okay, so this part was done. Uses and all was also done. And what about this baking soda? Formula is this one, and how this is produced. It is produced on a large scale by treating cold and concentrated solution of NaCl. This is my NaCl. It means a brine solution. Brine solution mainly consists of two things, right? Salt and water. So this NaCl is my salt, H2O is my water. This one is ammonia, this is carbon dioxide. It's producing NH4Cl and NaHCO3, right? And NaHCO3 is nothing but my this one, baking soda. And yes, after this, when we got this product as a baking soda, if we will heat this baking soda, then we will get this as a product, Na2CO3, carbon dioxide and water. Na2CO3 is what? Sodium carbonate. Okay, CO3 is carbonate. Here also CO3 is sodium carbonate. Okay, so till this, any doubt, any confusion in any of the equations, chemical reactions? No? Okay, so let's start with the uses. This also I discussed now, oxidizing and reducing agent. Just a minute, see this one. What is the oxidizing one? It's a substance that causes oxidation by accepting electron. And here my Cl minus what? Cl minus accepts what? Electron, right? And it get reduced. Why? Because it's having a extra electron. And what about this Na plus? Na plus is not having that much of extra electron. That's why what happened? Just a minute.
Mom, can you show the reaction to make sodium hydrogen carbonate again?
Yeah, which one?
And the reaction to produce sodium bicarbonate.
This one? Okay, this one. Baking soda. Okay, I'm
Yeah.
sure. One second. One more time. Let's say here. This is my baking soda. Okay, my voice is audible. Screen is visible.
Yeah.
Okay. So baking soda formula is what?
Yes.
Baking soda formula.
NaHCO3.
Yes, NaHCO3. This is what? Sodium bicarbonate, right? Sodium bicarbonate. Okay, this is my sodium bicarbonate. Now it is produced on a large scale by treating cold and concentrated solution of brine. Cold and concentrated solution of brine. As I've already told you that what is a brine solution? It's what? It's basically consists of two things, right? NaCl and water, right? So it produced on a large scale by treating this cold and the concentrated solution of this brine solution with ammonia and carbon dioxide. With ammonia and carbon dioxide. So this is brine, not brine. Okay, BRIME. Here, by treating with this this one is this simple. Only the thing you have to understand that here we have to treat the brine solution with the ammonia and carbon dioxide. Now what is my brine solution? Brine solution is NaCl and water, and I'm treating this with this thing, ammonia. Ammonia is NH3 and carbon dioxide, right? So what we will get? We will get NH4Cl and NaHCO3. What is my NaHCO3? NaHCO3 is my baking soda. Now you got it? Here just we are treating the brine solution with the ammonia and the carbon dioxide. Okay? Okay, now you got, see here. It is produced on a large scale by treating cold and concentrated solution of the NaCl. NaCl, if I am writing NaCl and water, see here, I have already taught, where's the brine solution? Yes, see. This was what? This was a brine solution. Here in this beaker, I've put the brine solution and I put the two electrodes, है ना, of cathode one and the another one is of anode one, right? Yes. Okay. And here I took which solution? Brine solution. See, brine solution is called what? NaCl and water. Water is H2O, NaCl is Na plus and Cl minus. That's why here I am writing that we are producing this on a large scale by treating brine solution with ammonia and carbon dioxide. It's very simple. Brine solution, just now I have told कि it's a combination of these two, the salt and water, and if we will react this with the ammonia and CO2, it will produce what? It will produce the NH4Cl and NaHCO3. Okay, now you got it? Yes, Safia, are you there?
Yes, ma'am.
So got it now? Okay. So now you tell me how we will prepare a brine. Sorry, no. First you tell me how we will prepare a bleaching powder. Come on, tell me very fast.
Ma'am, bleaching powder is a CaOCl2, and we can prepare that by the action of chlorine on dry slate lime.
Very good. Yeah. Hello, Rudra. Rudra, you. Yeah. Till this. Till this topic you was there na, last class you wasn't there, right?
Yes, ma'am, but it's fine. I actually finished this chapter before school.
So you finished? Okay,
Yes.
so now you will tell me ki how to prepare a bleaching powder. Matlab, what's the chemical reaction of a bleaching powder? First of all, tell me the formula of this chemical formula. Come on, first.
Just a second. Can I get my notes?
No, no notes.
I don't remember.
Okay, get your notes. But you will see and then you will tell me it's very easy process. Okay, get your notes first. So, Safia, yeah, you was correct. It's CaOH, sorry, CaOCl2.
Is it CaOH2 plus Cl2?
CaOH2 plus Cl2, it's a reaction, but I'm asking the formula.
CaOCl2.
Yes, the formula is CaOCl2. Now, what is the full form of this?
Calcium oxidichloride.
No, calcium oxychloride.
Oh.
Calcium oxy. Cl2 is nothing but chloride, okay, not dichloride. So, calcium oxychloride. And how we will prepare this? We will prepare this by action of what? Rudra, come on.
CaOH2 plus Cl2.
Yeah, with the action of chlorine on dry slaked lime, right? So here if we will do with like CaOH twice, this is nothing but dry slaked lime plus Cl2, chlorine on this means chlorine on this, then we will get CaOCl2 and some water. This is my calcium oxychloride. This is how we prepare a bleaching powder. Now Rudra will tell me what's the use of this bleaching powder. Come on, fast. What is the use of this bleaching powder?
Ma'am, it's an oxidizing agent.
It's an oxidizing agent. Good.
And it's used for bleaching clothes like cotton, linen.
Cotton, linen, yeah. And used for disinfecting drinking water, है ना, to make it free from germs and all, right? Okay, now just a minute. Yes. And what was about that, Rudra? The baking soda one. Tell me the formula of this baking soda. Come on, fast. Baking soda.
NaHCO3.
And what is the name of this NaHCO3?
Sodium bicarbonate.
Sodium?
Bicarbonate.
Yeah, sodium bicarbonate. Means this chapter is finished, right? In your school?
Yes, ma'am.
And what's next going on? Bye.
Now we started with the next chapter. I think it's called, forgot the chapter name.
Fourth chapter. What is the fourth chapter?
The one after this one.
Huh?
The chapter after this.
The chapter after this? Okay, wait. Let me check the chapter after this. It's analytical chemistry uses of sodium and ammonium hydroxide.
No, ma'am, I think it's metals and non-metals
What?
in the NCRT
Yes,
book.
that was a normal.
Okay. Yeah. What's Sophia? Okay. So the reaction of this you all know. Here we have to do what? Here we have to treat the brine solution with the ammonia and the carbon dioxide. If we will treat this, then we'll get NH4Cl and NaHCO3. Now, what is the uses of this baking soda? Any point? Any idea what is the uses of this baking soda? Come on. Okay.
It's used in preparation of food.
What? It is used?
I'm used to cure acidity.
Acidity, yes. used as an anti-acid, used as an anti-acid to treat acidity of our stomach, right? To treat acidity of our stomach. In acidity, we consume what? Basically, eno, right? But if let's say ki eno is not present in our home, then we can also mix this baking soda with water and we can have it. Okay, if eno is not present, we can use this baking soda and water and we can have it to reduce the acidity which is forming in our stomach. Okay, so it acts like a eno also, because eno is basically which is used to reduce the acidity. So eno is equal to the baking soda. Baking soda also helps to reduce the acidity. We'll mix that with water and we'll drink it. Now, what is the next point? Used to make baking powder, which is used in the preparation of cakes, breads. Okay, this baking soda is useful for making the cakes and breads. Now, anyone tell me ki how baking soda make fluffy our dish? Ki how cake become fluffy, right? The fluffy round shape. How come? How this is happening? How come fluffy is happening with the help of the baking soda? Come on, anyone? With the help of what? With the help of which gas this fluffiness is coming? Anybody? Nobody?
Is it tartaric acid?
Is it?
I'm not sure.
It's CO2. It's carbon dioxide. Upon activation, what happens? CO2 is produced. And if CO2 is produced, then what CO2 will do? CO2 will make these small holes in our cakes or in our dishes. And with the help of that small holes, it makes fluffy to our cakes or breads. Okay? It rise and become a light and fluffy type of. Okay, so with the help of the carbon dioxide, it makes small holes, and with the help of the small holes, the thing got rise and becomes light and fluffy. Okay, with the help of only the carbon dioxide. Now, what is the next point? Next point is used in soda acid fire extinguisher. Okay, so this baking soda is also a help in the fire extinguisher. Okay, so here let's go with this notes. Uses of the baking soda for making baking powder. For making baking powder, which is a mixture of baking soda and a mild edible acid such as tartaric acid. When baking powder is heated or mixed in water, the following reactions takes place. So here the carbon dioxide produced during the reaction, and a mild edible acids such as tartaric acid. But here what happens, the carbon dioxide produced during this reaction, because of this carbon dioxide, my bread or cake, it helps to rise, making them soft and spongy. Okay, because of this gas is produced during this reaction. What is the reaction? Reaction is sodium hydrogen carbonate with this acid. This acid is such as tartaric acid. Rodhu, you was right. That was you were telling the the reactions, the tartaric acid and the sodium hydrogen carbonate. But the product is, but I'm asking the product. So what was the product? Product is the CO2. Due to the CO2, my cakes and breads rises and it becomes fluffy. Okay, so the reaction is this: sodium hydrogen carbonate, which is NaHCO3. NaHCO3 is the formula also of my baking soda. If we will react baking soda with tartaric acid, it will produce carbon dioxide and water plus sodium salt of acid. Now, with the help of this carbon dioxide, it makes fluffy to our breads or cakes. Okay, remember this reaction. So this reaction is very easy. Okay, very easy. 1 second. Okay, so now anybody tell me the reaction of this, how we will make our dish fluffy. Just now I have told, right? Now anybody, come on, let's say here. Anybody? Now tell me. Come on, tell me how to make our dish fluffy. What we will use, Safia?
Yes.
What we will use, Safia, to make our dish fluffy?
Baking soda.
What is baking soda? Baking soda is NaHCO3. We will treat this baking soda with which type of acid? With tartaric acid. Tartaric acid is H plus. We will get what? We will get carbon dioxide and water. So with the help of this CO2 only, it makes our dish fluffy in nature. Okay? See, it causes bread or cake to rise, making them soft and spongy. Okay, so this part you got. Now anyone will ask you ki how, why our bread rises, how this thing is like got spongy and softy. Then you will tell ki okay, like this if we are mixing the baking soda and the acid, we are getting the CO2, and with the help of CO2 there are small holes, and that small holes, the CO2 is helped to make our fluffy in nature. Okay, got it everybody? Rudra, you? Yes, Rudra, what about you? You got it?
Yes, ma'am.
Okay, now tell me what was the formula of this? Come on. Just now I told, na? Fast, Rudra. Just now I told you. Baking
Did
soda.
you ask?
Yes.
What
Go
did you
ahead.
ask? I couldn't hear
The
you.
formula of how we are producing the carbon dioxide. There was one formula, right? We are mixing with the tartaric acid. So what was that chemical reaction?
NaHCO3 plus H gives Na plus CO2 plus H2.
Na plus CO2 plus H2. Yes. So now this thing is clear, I guess. Okay. Now what is the next point? Sodium hydrogen carbonate, means our baking soda, is also an ingredient of antacids. Yes, antacids is what is basically used to treat our acidity. Okay. Being alkaline, it neutralizes excess acid in the stomach and provide relief. If we will take baking soda acts as eno only. Okay, if we'll take baking soda, it helps to reduce our acidity. So here we are taking the sodium hydrogen carbonate with the HCl. It's producing the sodium chloride, water, and the carbon dioxide. Okay, so it acts as an antacid. Now it is also used as soda acid fire extinguisher. This baking soda is used in this one, the soda is used in this soda acid fire extinguisher. Okay, we will learn about this washing soda. Now what is the formula of this washing soda? Anybody? Come on, any one of you tell me the formula of this washing soda. What is it? No one? Rudra, come on, you tell me. You already learned all this, right?
Yes, ma'am.
So tell me the chemical formula of this washing soda.
Yes, ma'am.
What? Wait a second. No need to see don't see in your notes. Just tell me. Okay, come on. Okay, Safia, you any idea about this washing soda formula?
Na2CO3.
Okay, Na2CO3 dot 10H2O. See, Safia, wow. Okay, good. This is what? Na2CO3 dot 10H2O. This is what? This is sodium carbonate. Okay, Na sodium CO3 is carbonate. Now, how we will form this washing soda? Sodium hydrogen carbonate. This is my sodium hydrogen carbonate. Okay, Na is sodium, H is hydrogen, CO3 is carbonate. Now here sodium hydrogen carbonate, on heating, if we will heat this, if we will heat NaHCO3, it means what was my NaHCO3 there? That was my baking soda, right? So if we will heat this baking soda, then what will happen? On heating, it decomposes to give a sodium carbonate. On heating, it decomposes to give what? To give sodium carbonate with the release of the hydrogen gas. So here, if we are heating a baking soda, baking soda only. If we will heat this baking soda, we will get what? We will get Na2CO3. And what is my Na2CO3? Na2CO3 is my washing soda plus some water and plus some carbon dioxide. This is the very easy chemical reaction of this washing soda. Only we have to heat a baking soda, we'll get a washing soda. And how we are getting a baking soda? Baking soda, we are heating a brine and the ammonia and the carbon dioxide. And how we are getting this bleaching powder? Bleaching powder we are getting by the action of chlorine with a dry slag lime. We are getting a bleaching powder. Baking means the brine, ammonia and yes, carbon dioxide. And if we will heat the baking soda, we'll get a washing soda, Na2CO3, water and some carbon dioxide. Now recrystallization of sodium carbonate This is my sodium carbonate. Recrystallization of sodium carbonate produces a washing soda. If we will recrystallize, if we will recrystallization of Na2CO3 means sodium carbonate, and Na2CO3 by recrystallization we are producing Na2CO3 dot 10H2O. This is the formula of the washing soda. See, this is the formula of the washing soda. Okay, on recrystallization, we are forming a full washing soda with 10H2O added. Now, through baking soda, we made what? We made a washing soda, right? Through baking soda, we made a washing soda. And on recrystallization, we are producing this also, 10H2O. Tell I'll tell you guys later ki why, what is the use of this 10H2, why we write 10H2O dot 10H2, why we are writing like this. Okay, I'll tell you later. Okay, so now this part cleared. Everybody, Safia and Rudra, this was the easiest one. On heating the baking, we are getting a washing. Baking, washing. Baking, heat, washing. Okay, Safia, you got it?
Yes, ma'am.
It was easy or not?
Yeah.
Okay, and what about you, Rudra? Now, Rudra, you tell me again what is this chemical reaction only of this washing soda. But don't see your notes. Without
Oh,
seeing
yes.
your notes. Huh.
Do I tell like what sodium carbonate is?
Yes. No.
Um,
The chemical reaction.
Oh, like how it's formed.
Huh.
NaCl plus NH3 plus CO2 plus H2O gives NaHCO3 plus NH2Cl.
Now, if we will heat this, this is my baking soda. If we will heat this, we will get a washing soda. We'll get a Na2CO3 and some water and some carbon dioxide. This was the reaction, right? Okay.
Yeah.
And on recrystallization of this again, we'll get what? We'll get Na2CO3 dot then H2O. Okay, so this part is clear. Now we'll go with some notes. See, note, baking soda is also reacts as a preservation for milk. In summer, it is added to a milk. Acha, this one, na, baking soda is also react as a preservation. In summer, it is added to a milk. As milk decompose and release lactic acid, which makes milk sour, added NaHCO3 reacts with acid to form some salt and water. It neutralizes the acidic effect and milk does not become sour. This was actually the point of the baking soda. Now, from here, my washing soda is starting. So, washing soda is what? The sodium carbonate is a white crystalline solid. Obviously, we all know this is my what? Washing soda. This is a type of what? White crystalline. Our surf, detergent, all kind is what? All of them is what? Some white crystalline solids, right? Its solution in water is alkaline in nature. If it's alkaline in nature, then it turns red litmus into blue. It has the property to remove dirt, grease from the dirty clothes. Obviously, the detergent, the Nirma and all, you know, it remove what? They help to remove the dust and the grease from the dirty clothes. Thus, it is known as the washing soda because it washes our clothes to remove the dirt and all the dirt only, the dirt and grease. Sodium carbonate can be obtained by heating a baking soda. The recrystallization of sodium carbonate gives a washing soda. Okay, sodium carbonate can be obtained means the Na2CO3 can be obtained by heating a baking soda, which was NaHCO3, and on the recrystallization of Na2CO3, we will get a Na2CO3 dot 10H2O. Okay, now what are the uses of this washing soda? Used in glass, soap, paper industries. This washing soda is also used in paper industries. Paper industries, soap, obviously soap, that Rin bar, Surf Excel, all are kind of a washing soda only because all helps to wash our clothes, right? Employed in the manufacture of sodium compounds such as borax, it can remove permanent hardness of water. It can remove permanent hardness of water, yes. It can remove Permanent hardness. Permanent hardness of water means dirt only. Okay. Permanent hardness of water is equal to dirt or grease. And with the help of this, we remove these kind of dirt from our clothes. Now we will go through these points. Washing soda. It is used in glass, soap, and paper industries. It is used for the manufacture of sodium compounds like borax. Borax, yes. Washing soda. With the help of washing soda, it is used for the manufacture. This washing soda is useful in the manufacture of the sodium compounds like borax. With the help of the washing soda, we manufactured which thing? We manufactured this borax. It also removes permanent hardness of water. It is used as a cleansing agent like detergent in houses and laundries. Okay, cleared? This was the easiest one. Now, what is the plaster of Paris? Now, what's the formula of plaster of Paris? See, this is the plaster of Paris. If anyone got fractured and all right, then we used to cover their hands with the plaster of Paris only. Plaster of Paris also helps to make these types of what? Architecture and all. Okay. Now, Rudra, what is the chemical formula of this plaster of Paris?
CaSO4 into half H2.
Okay, good. CaSO4 into half H2O. And this plaster of Paris is prepared by heating gypsum. Plaster of Paris is prepared by heating gypsum at 373 Kelvin. At 373 Kelvin, here it's written. It is obtained by heating gypsum. This is the formula of the plaster of Paris. If we will heat this gypsum at this temperature, 373 Kelvin, at this temperature, gypsum loses water molecules and forms a plaster of Paris. Okay. If we will heat a gypsum, then what will happen? The gypsum will lose the water molecules and it will form like this, the plaster of Paris. This is the chemical reaction. This is what? This is the formula of my gypsum, CaSO4.2H2O, and the plaster of Paris is CaSO4 half H2O. Okay. So this gypsum is 2H2O. If we will heat this at 373 Kelvin, we will get our plaster of Paris and some 1.5 water. When gypsum is heated above 400 Kelvin, dead burned plaster is obtained which does not have the property of hardening. Okay. Plaster of Paris is nothing but obviously the hard thing, right? If anyone will get a fracture in anyone or in anywhere, then what will happen? Will cover their body with some hard kind of thing, right? Because to help our the hard thing helps our bone to fit in their respective place. So if we heat a gypsum more than 373 Kelvin, then what will happen? It will lose its property of hardening. And when it will lose its property of hardening, then obviously it's not called a plaster of Paris, because plaster of Paris is kind of a hard sculptures. Now, here what's written, the plaster of Paris is a white powder and on mixing in water, it changes to gypsum, giving a hard solid mass. Okay. And if we'll add a plaster of Paris with some water, then it changes to gypsum, giving a hard solid mass. Okay. What is the uses? It is used by doctor for joining the fractured bones at right position for making plaster to support fractured bones. And a plaster of Paris supported our fractured part. It is also used for making decorative pieces and for making designs on ceilings. In ceilings, is there in our room, it's also with the help of this plaster of Paris, only the hard part. Okay, so this plaster of Paris part is cleared. Here, what's happening? Only the simple thing. The gypsum is heated with the at 373. We are getting plaster of Paris and water, and again we are combining the plaster of Paris and water to create a what? To give a gypsum as a product. It changes to gypsum, giving a hard solid mass. Okay, and if we will heat a gypsum more than 373 or more than 373 only, then what will happen? It will not have that hardening kind of a property. Okay, understood everybody? Safia and Rudra, yes, come on.
Yeah, yes.
Okay. Next is what? Water of crystallization. But first, let me come over here. This is what? This is simple, the preparation of the normal salt, the insoluble and the soluble one. This was from insoluble. Here first we talked about the five kind of salts: common salt, bleaching powder, baking soda, and washing soda. We are forming this washing soda with the help of this baking soda only. When we'll heat this, we'll get a washing. How we are getting a common salt? Common salt is easy. Here we are taking one brine solution. Brine solution is nothing but the addition of two things, some salt and some water. We are taking two electrodes, the cathode one and the anode one. Here, if we are taking in the brine solution, it's NaCl. Na is Na plus Cl minus. Na plus is what? Na plus is not having extra electron, so it needs one extra electron. If it will need one extra electron, then what will happen? After this is formed, this solid sodium is formed, then what will happen? It will react with water. When it will react with water, it will produce these two things, the hydrogen gas and some sodium hydroxide. And what about this chlorine one? Cl minus is what? Cl minus is means it's having one extra electron, right? So what will happen in this part? The chlorine, if where was that? The Cl thing. Okay. Okay, this only, sorry. This was the reaction, right? Cl2 and 2. See, here what's chlorine gas and here is my chlorine gas. So this was the full diagram of a common salt. Next was my bleaching powder. Bleaching powder was the easiest one. No, the washing soda was the easiest one. What's there in the bleaching powder? It's CaOCl2. It's very easy. By the action of chlorine on dry slag lime, the chlorine and the dry slag lime, then we'll get a bleaching powder and some water. Chlorine with the addition of the chlorine and the dry slag lime. Okay, we'll get bleaching powder and water. And what about this baking soda? Baking soda was the easiest one also. The brine, the ammonia, and the carbon dioxide, we are getting a baking soda. And what about the washing soda? Washing soda is, if we will heat a baking soda, we'll get a washing soda and some water and some carbon dioxide. And what about the PPOP, plaster of Paris? Here is the simplest one, CaSO4.2H2O, and this is CaSO4.half H2O. We are heating a gypsum at 373 Kelvin. On heating, we will get some plaster of Paris and a water. And if we will combine this plaster of Paris again with this water, this half H2O, we will get a gypsum, CaSO4. Obviously, the reverse process is going on, right? Of combining from this, if we will heat, we'll get these two products. These two products combining, we'll get obviously one product, the gypsum only. So if we will heat a gypsum with the above temperature of 373, then it will lose its property of a hardening. Okay, and the gypsum and the plaster of Paris is used for the fractured bones, and it's also used for these sculptures like this, and making designs on our ceilings, and also for some decorative pieces for decorative purpose. Okay, any doubt, anybody? Come on, tell me. Now you guys will memorize these all chemical reactions because this was easy only. And yeah, and on heating this baking soda, we will get this also, the sodium carbonate, carbon dioxide and water. Okay, any doubt? Come on, tell me, Safia and Rudj. Fast. Any doubt?
No.
Okay, Safia, what about you? Any doubt?
No, ma'am.
Safia, in the next class, I'll ask each one of you like all the formulas, all the chemical reactions. Okay, so be prepared. And in the next class, we will learn about this laboratory preparation of some important salts, iron 3 chloride, copper 2 sulfate, and what about this? Zinc sulfate, calcium, lead chloride, sodium bicarbonate, and the last is some general property of salts. Okay, that salts are non-volatile directly from electrovalent compounds. Okay, so thank you everybody. Next class, be prepared. Bye-bye.